Magandang buhay mga katusok. Again, welcome to our video lecture, and in this lecture, what we're going to discuss is all about chemical bonds. For this lecture, our learning outcomes are the following. Number 3.1 is to identify the correct formula of ionic and covalent bonds, and of course to identify covalent bonds as polar or non-polar. For learning outcome number 3.2, we're going to discuss that in our synchronous session. Okay, so what will be the overview of this discussion? We're going to discuss the octet rule, no? Naming anions, cations, ionic covalent bonds, naming covalent bonds, okay? Polar and non-polar covalent bonds. Now, it was Gilbert Lewis in the year 1916 pointed out that the lack of chemical reactivity of the noble gases indicates the high degree of stability of their electrons configuration or electron configuration. As you will see and you will remember, no, these electrons or these elements are already on what we call the octet rule, or they only follow already the octet rule wherein their electrons are already stable, no? Unlike the other elements wherein they can share or they can lose, no? Noble gases have already fulfilled, no, its stability. Stable na po sila, unlike the other elements. Okay? And remember, it was Lewis who formulated that. And as we go to the discussion, we'll be able to take note. Ano ba yung contribution? What are the other contribution or significant contribution of Lewis in the field of chemistry? Now, as you can see in this picture, in this illustration, ang sabi dito, Lewis, the original bonding scientist, because it was Gilbert Lewis who postulate or illustrates how does the bonding occur. Okay? Kung paano po nagte-take place yung sharing of electrons. Okay? So in octet rule, the tendency of group 1A to 7A elements is to react in a way that will achieve an electron configuration of 8 valence electrons. No? That's what the principle of octet rule, to be stable. Now, we have what we call cations and anions. An atom that loses one or more electrons becomes a positively charged, then that is what we call cations. And anions is the one with gain, or the one who gain or accepts one or more electrons, thus it gives the name anions. No? Uh, a lot of students are confused which is the positively charged ions and which is the negatively charged ion. But just to give you a basic review, you know, on how are you going to remember what happened, on how are you going to remember cations and anions, it's basically a very simple way. No, there is a simple way on how are we going to take note, on how are we going to remember that cations are the positively charged ions and anions is the negatively charged ions. Okay, as the word implies, cation and an ion. No, this will be funny to all, but I want you to remember this because it will help you to take note that cation is the positively charged particle, the positively charged ions. No? So how are we going to take note of that? Cat is, in Tagalog, is pusa. No? Pusa. Plus tive is the pusative. No? That is our cations. Cations is the pusative. Okay? Cations is the positive ions. And anions, how are we going to take note that anions is the negatively charged? Okay? How are you going to take note that anions is negatively charged? Then it's up to you. Matanda ka na, kaya mo nang tandaan na ang anions ay ang negative kasi ang cations mo na is your positive or positively charged. I hope that will be clear to you that ions are the positively charged, or cations are the positively charged because of the positive, no? And anions is the negatively charged, or the opposite of what we call positively charged ions. I've mentioned that cations tend to give, no, its electrons, and anions tends to accept, no, electrons. Now, in order for you to remember that, let's put it in a layman's term so that you will always be remember why cations, or how can anions share or give, no, lose, and how anions accept or gain. Take note, we said that cations are positively charged. In life, if you are positive, you are tend to give, you are happy, no, you are willing to give anything that you can give for someone to fulfill its dream. And when you are negative, there's something wrong, there's something missing in your life, right? If there's something missing, you need something that will fulfill, or that will fulfill your loss, that will fulfill your happiness. Since that you are negatively charged, you need something, and that something will be filled by our cations. Then cations, since cations are positive people, positive charge, they can give. And once you and an ion accept the electrons given by these cations, then you will be stable. Okay? So it's the same principle in octet rule. Anions are unstable because they lose, or they lack of electrons. They need something that will make them fulfilled, that will make them stable, that will make them enough. No? And this enough, no, in this anions to be enough, will be filled by cations, the electrons shared by cations. I hope you get what I mean. No? Since that you are negative people, you're looking for someone, you're looking for something that will make you fulfilled. That is anions, negatively charged, tends to accept electrons from a positively charged people. Okay? So please take note of that. Cations is the positively charged, they give. They are willing to give. They are willing to lose. And ions, negatively charged, they accept so that they will be fulfilled, so that they will be stable. Okay? Usually, cations are metals and anions are nonmetals. Now, how are we going to name an ion? So there's a very simple way on how are you going to name an ion, cations rather. Just have to remember the name of the electrons, or the name of the element. Okay? Just have to remember the name of the element, and you just have to fix or to add the name ion. So, for example, we have here hydrogen plus the word ion to make it hydrogen ion. Lithium to make it lithium ion. Sodium, sodium ion, and potassium, potassium ion, and so on and so forth. But I want to have a things to clarify. I want to clarify some things. Okay? Please take note on this. If we write this in this way, then that is the element. Okay? Remember, that is the element. Okay? But if we write with charge, or this way, then that is the ion. This one pertains to 1s1. The electron configuration is 1s1. Meaning to say, this element has one valence electron on its outermost shell, valence shell, which can be loose no? Which can be loose or donate. And this one pertains to ion, which means this hydrogen or this symbol pertains to an element who can give one ion, and that is the hydrogen. Take note, if I said in the exam or in quizzes, hydrogen ion, then you have to write it with this way. If there is the word ion, then you have to indicate the charge. If I said hydrogen and I asked you to write the chemical or the symbol, then that will be a plain H. If I said hydrogen ion, then that will be this way. I hope it's clear to all, so that there will be no confusion when time comes that I will ask you to identify which among which is an ion and which among is an element. Okay? So again, basically, in naming cations, no, just have to retain the word or the name of the metal to be followed by the word ion. And then the charge indicates the number of electrons that it can share, the number of electrons that it can lose, it can give to someone in order to fulfill the octet rule, okay, or the stability. However, there is always an exemption in the general rule, okay, because there are elements which requires the use of its systemic name or common names. Most especially the transition metals or the inner transition metals or elements, no? Most of which form one type of cation, more than one type of cation. Okay? There are two options on how are we going to take note of this. It can be using the systemic name or it can be using their common name. If you're going to use the systemic name, then you have to remember and you have to use the Roman numerals, which will indicate, the number of electrons that it can share. And take note that if you're going to use systemic names, since you have to use the Roman numerals, then it must be enclosed in parentheses. However, if you're going to use the common name, then you have to use the suffixes OUS and the IC, no? That will be depending on the number of electrons that it can share. Okay? Let's say for example, for copper, we have cuprum, which the Cu of iron comes from. So instead of saying cuprum 1 ion, then we can say it is cuprous ion. Instead of saying cuprum 2 ion, then it will be nice if we're going to say it as cupric ion. The same thing goes with uh, iron. No, ferrous ion, ferric ion. Ferrous ion is the iron 2. Ferric ion is the iron 3. Okay, the same thing goes with mercury. Mercury 1 ion and the mercury 2 ion. Mercury 1 is the mercurous. Mercury 2 is the mercuric. Okay, and tin, stannous ion and stannic ion. Now, what will be our mnemonic in order to remember? If you're going to use it is the element or it is the uh, more electrons that it can share. Di ba? Mas mataas, mas madami siyang electrons na kaya niyang i-share. Ik. Kapag always yun yung mas mababa, cuprous, kaya lang niyang mag-share ng 1 electrons. Kapag cupric, dalawa. Okay? So take note of that. And we also have what we call the anions. How are we going to take note the names of anions? In naming anions, you have to remember, number one, retain the stem name. When we said the stem name, the original name of the anions or the original name of elements, removing the prefix as the suffix, because you have to change the suffix by IDE, which will indicate us that it is an anion. Okay? In cation, we retain the name of the element plus we add the word ion to identify it as an ion. But in anions, you have to use the stem name and change the suffix into IDE, which will indicate us, which will help us to know that it is an anion. Let's say, for example, hydride, fluoride. From fluorine, inalis yung INE, change to IDE, which will becomes fluoride. When we said fluoride, how are we going to write fluoride? F with a negative charge. How are you going to write fluorine? A simple F. That will indicate that it's a fluorine. Okay? Please remember, if we have cations and we have anions, definitely we have also what we call polyatomic ions. And from the word itself, polyatomic ions, meaning to say, it is composed of more than one ions. It is composed of more than one element. It is composed of more than one atom. Okay? And we have here the list, no? Ayan, nandyan, no? In my screen. I have there the list. We have there the list of our most commonly used polyatomic ions. Sure, what do we need to do? The thing that you need to do is to remember it by heart. Not just remembering it by heart, but to love it. No? You are always hear the word love because you have to love. No? When you love, you will understand. Okay? So again, take note, you have to love this. You have to remember this by heart. Okay? Because when during our exams, no, wala na po kayong index card na hawak so that you will guide you on how to name polyatomic ions. Why I am asking you to take note of this? Because it will help you to understand on how are we going to name compounds. Because if you don't know that these elements, that this uh, molecule or ions occurs as polyatomic ions, then it will be too hard for you to understand and to identify the name of the compound. Okay? So for you to remember, then you have to take note that there are what we call polyatomic ions that occurs in more than one ion, more than one element. Okay? So now, we have a review on how we're going to name ionic compounds. Please take note, people of the Philippines, that ionic compounds are usually composed of metals and nonmetals. Madali siyang tandaan. Kapag ionic compounds, it is composed of metals and nonmetals. And as we discussed in our previous slides, ang sabi natin, metals usually are cations and nonmetals are usually anions. So meaning to say, ionic compounds are combination of combination of metals and nonmetals. Okay? Combination of a positively charged and a negatively charged ions. So there's two basic steps on how we're going to take note the names of our anion, of our ionic compounds. We have to name the metal ion and we have to name the nonmetal ion. So let's have an example. Assuming that we don't know what's the name of this chemical, we have here CaBr2. And if we're going to dissect, no, CaBr2, we have two elements here, calcium and bromine, right? In our steps, in our slide, ano yung sabi sa atin? Write the name of the metal ion, which is metal, calcium. Then we have calcium ion, plus the name of the nonmetal anion, no? Which is your bromide. Again, hindi po siya bromine. Kasi pag bromine, element siya. What is written in our instruction is write the name of the non-metal ion. Okay? So, metal and ion, that is an ions. Then you have to indicate it and you have to name it using the suffix IAD. So, having said that we have calcium ion and bromide ion or bromide, by removing the word ion in calcium, we have here calcium bromide. Then that will be the name of our CaBr2. No? That's how we're going to read it. Calcium bromide. Let's have an example. NaF, MgO, SrCl2, Li2S, CaO, and Ki. So NaF, we have sodium ion and fluoride. So we have sodium fluoride. MgO, we have magnesium and oxygen or oxide, that will be magnesium oxide. Sr2, that is our strontium chloride. Li2S, that will be our lithium sulfide. No? Calcium oxide is CaO. Then Ki is our potassium iodide. If you're going to analyze the composition of this element, of these compounds, again, they are composed of metals and nonmetals. They are composed of a positively charged ion and a negatively charged ion. Another example here, we have now the polyatomic ions. Now, if you don't know that these are polyatomic ions, then it will be too hard for you to take note what will be the name of these compounds. Because as what we have discussed in the previous slide, sabi natin, we have to indicate the name of our non-metal ions and metal ions. But basically, in these examples, now we have more than two elements, which will make you confused if you don't know that they are what we call polyatomic ions that exist in the world of chemistry. So, how are we going to do that? You have to remember and take note this polyatomic ion. So, number one, NH4 is your ammonium. F, fluoride. Then that will be ammonium fluoride. CaSO4, that will be our calcium sulfate. SO4 is sulfate. MgNO32 is your magnesium nitrate. And we have NaOH as your sodium hydroxide. And H4, take note, NH4 is polyatomic, SO4 is polyatomic, and O3 is polyatomic, OH is polyatomic. No? This is what I am telling a while ago. If you don't know the polyatomic ions, then it will be too hard for you to name this. Because if you're going to follow what is the way on writing or giving the names of our ionic compounds, using having a cations and anions or having a metal and non-metal, then you will write it as hydrogen, number one, nitrogen, hydrogen fluoride. In naming compounds, no, kapag pangit yung kanlabasan ng pangalan, don't accept it. Ibig sabihin, hindi yun yung tama. Okay? So take note. There are what we call polyatomic ions that you have to remember and you have to love. Example. Another example. CaCl2, that's simply your calcium chloride. K2S is your potassium sulfide. KMnO4, o yan. If you don't know that MnO4 is your permanganate, no, it will be too hard for you to name this KMnO4. That will be your potassium permanganate. BaO, simple, barium oxide, because it's composed of metal and non-metal, barium, ion, and oxide. Ganun lang kapag madali. Kapag hindi siya polyatomic ions. How about the polyatomic ions? No? Siguro ngayon, uulitin ko yung sinabi ko sa mga previous kong video. Natatawa ka na kung bakit kailangan mong tandaan at alamin itong mga polyatomic ions na yan. Number 5, we have NH4Cl. No? Ang pangit naman pakinggan ng NH4Cl na ikaw ay isang medtech student, you don't know How are you going to name NH4Cl? You don't know how to read it. That will be your ammonium chloride. CSCl, di ba ang pangit? CSCl, parang hindi ka science student if you don't know how to name compounds. Now, that will be your calcium chloride, and MgSO4, that will be our magnesium sulfate. Now, if writing the chemical formula or the chemical name is you have to indicate the metal ion and the non-metal ion, but this time, how are we going to take note the chemical formula? When it said chemical formula, it pertains to the symbol, no formula, that will give us the number of atoms of an element present in an equation or present in a compound. No? If you still remember my question in our forum, what do you think is the most important factors in naming or in balancing equations? No, some of you are saying the law of conservation of mass, which is correct. I will not argue if you said that it's one of the most important factors. But aside from that, aside from knowing that the mass of the reactants and the mass of the product must be the same mass, then one of the best thing that you have to remember aside from that is the chemical formula. Because the chemical formula or the chemical formula will give us an idea or will give us the ratio of the atoms present in a chemical compound, in a chemical compound, no, a chemical in a compound rather. So if you don't know the chemical formula, then it will be too hard for you to balance. If the chemical formula is incorrect, then kahit pa from 6 a.m. hanggang 12 midnight kang mag-balance at mali ang chemical formula mo, you will not arrive with the exact or correct balance equation. Now, before we balance equation, before you write chemical names, dapat alam din natin on how we are going to write the chemical formula. And there are two basic steps on how we're going to do that. Number one is write the symbol of metal and non-metal ions, and you have to determine the charge. Since you have to take note the name or the ion, and when you said ion, it must have the charge. Then this charge will also give us an idea on how many electrons this certain element share or give to someone. Okay? So tandaan, yung mga naunang slides, mahalaga siya, kaya dapat alamin mo. Let's say for example, we have your magnesium iodide. So how are we going to take note the chemical formula of magnesium iodide? Ano yung sabi natin? You have to take note and you have to write the metal and non-metal ion. Magnesium, Mg. Iodide, I. And the next thing that you have to do is to take note the charge. Magnesium belongs to group 2A. Diba sabi natin, periodic table gives us an idea on how many electrons or what will be the charge of our ions. So since 2A siya, that will be 2 positive. Iodide, 1 negative. Non-metal, anions will accept, no? Will gain electrons. So we have Mgi2. Oh, how come that this becomes Mgi2? If you still remember your teacher during your high school days, ano yung sinabi nila sa iyo sa mga ganang pagkakataon? We have what we call the crisscross. I don't know if I spell Chris correctly, but we have that we call crisscross. So we have magnesium 2 plus and iodide 1 negative or negative, no? If the charge is 1, regardless it's a positively charged or negatively charged, then you don't have to write 1 anymore because it's understood that it is 1. No? Now, following what we said crisscross, no discharge, and discharge, pag-crossin mo lang sila, just have an alternate, no, or exchange numbers. Then since iodine or iodide possess 1, then that will be Mg, and magnesium possess 2, then that will be I2. MgI2 is our magnesium iodide. Okay? So that's how we name or write the chemical names or the chemical formula rather of our ionic covalent bonds. Okay? So let's have an example. So another example, iron 3 oxide. Take note of this. Iron is an example of transition element. Diba? This is a transition element which belongs to 1b to 8b. Kapag sinabi natin transition element, it can be written using its common name or the system name. So iron 3 is written in its system name. So we write here iron, Fe, and we have to write O. Take note of the charge, no? It's 2. So if you have the crisscross of 3 and 2, we'll have it Fe2O3. And Fe2O3, that will be your ferric oxide, or that will be your iron 3 oxide. Okay? So ikaw lang po yung masaya. Hindi, maintindihan mo rin siya, don't worry. Take note of this, my beloved students. If the ion ends with IDE or ends in IDE, it is probably from periodic table. It can probably non-metals, probably your anions. If ions ends in AET or ITE, it is polyatomic ion. So tandaan mo, no? Para hindi ka malito kapag maglalagay ka na ng chemical formula. Kapag IDE, it's an element from a periodic table. Kapag 8 or I, that is a polyatomic ions composed of more than one element. Example, potassium iodide, IDE. Ibig sabihin, this is an example of element. Potassium, K, positive. Iodide, I, negative. Crisscross, Ki. Tin, 4, chloride. Binigyan ka na ng idea, 4. Okay? Mayroon daw siyang 4 plus na charge. And chloride, negative 1, crisscross, SnCl4. Barium sulfate. Barium sulfate is BaSO4. I want to make it clear because some students are having confusions on the chemical formula of barium sulfate. Let me share my whiteboard. Yan. Sir, why students are having difficulty or confusions in barium sulfate? Bakit po ba yung iba ay nalilito, no, sa barium sulfate? Ano ba yung barium sulfate na yan? Bakit nakakalito yung chemical formula na? Kasi meron nagsasabi that the chemical formula of barium sulfate is this way. Meron nagsasabi na ang chemical formula ng barium sulfate is this way. But mind you people, that the correct chemical formula of barium sulfate is this one. No? The first two chemical formula is incorrect or incorrect. This is the correct chemical formula of barium sulfate. If you have to remember, or if you still remember, Barium is Ba2 plus. Sulfate is SO4 negative 2 charge. Sir, you said crisscross. O tama naman. Hindi ko kino-contest na ang sinabi ko kanina is crisscross. Correct. Crisscross mo sila, no? Kapag gincriss-cross mo yung mga charges na yan, will give you Ba2 SO4 2. You can divide, no? You can what you call this? Simplify. Instead of saying Ba2 SO4 2, since these two charges are these two subscripts are both divisible or multiples, then simplify it so that it will not be complex to you. Okay? So take note that this is the correct chemical formula for barium sulfate. Okay? Pag malilito ha, para hindi po tayo naliligaw ng landas. Alright, next is copper to carbonate. Again, madali siya kapag transition elements, binibigyan ka na ng idea, no? Aluminum bromide, that will be LBr3. Aluminum plus 3, bromine, negative 1 or bromide. Lithium nitride, Ni3, nitride. Hindi siya nitrite. So that's simply your nitrogen. Now, how about for covalent bonds? If we said that ionic bonds or ionic compounds are composed of nonmetals and metals, wherein metals tends to share or give rather, I repeat, ionic is composed of metal and non-metal, wherein metal tends to share. No more, not share, huh? Not share. Tends to give, lose. Okay? Lose. No? I am not editing my videos para kunwari sa totoong buhay pa rin tayo nag-uusap. Okay? Please make it clear, take note, that ionic compounds are compounds composed of metals and non-metals, where metals, give, donate, lose electrons for anions. Now, in covalent bonds, it is composed of non-metal and non-metal. Kanina, may nagbibigay, may naglo-lose, at may yung isa, nag-gain. In covalent bonds, in covalent compounds, they share. Yan, tama na yan. They share. They share the electrons to one another so that they will be stable. In ionic, metals give. Metals donate. Metals lose. In order for someone to win. In covalent, they share. Okay? Now, what will be the steps in naming binary covalent compounds? Write the name of the first nonmetal, followed by the name of the second nonmetal, and change the ending to IDE. Add prefix to specify how many element is present. Example, N2O4. We have nitrogen and we have oxide. Not oxygen, ha? Kasi you have to change daw the suffix into IDE. So you have nitrogen and we have oxide. What is good in covalent is it will give us an idea on how many electrons or elements are present because of its coefficients. Because of its subscripts. So nitrogen, we have 2. And using the prefix, then that will be di. Oxygen have 4. Using the prefix, we have tetra, that will be oxide. However, I want you to remember these rules of using prefixes. Number one, prefixes are only for binary covalent compounds. You cannot use prefix in ionic compounds. Next is the prefix mono is never used as prefix for the first element of a binary covalent compounds. Wala ka namang narinig na monocarbon monoxide. Wala ka namang narinig na monocarbon dioxide. If the element, the first non-metal element in the compound is only one, then there's no need to use the prefix mono for the first element. However, for the second element, we have two. Like for example, carbon monoxide. Hindi mo naman pwedeng sabihin carbon oxide, no? That will be incorrect. And every time that you have to put prefix to oxide, you have to remove the O or the A of the prefix. Let's say, for example, the previous example, dinitrogen peroxide. Instead of saying dinitrogen tetraoxide, which is very pangit in the ears of chemists, then you have to remove the O from the prefix, A rather, from the prefix tetra, and just add the name of the second nonmetal. So in our previous example, we have dinitrogen tetroxide instead of saying tetraoxide. No? But in IUPAC, they consider that tetra. No? But in common names, no, don't have to use tetra. Or we have to remove O, we have to remove A in the prefixes for oxide. That's for example, monoxide. Ano ang monooxide? Double mono, M-O-N-O, O ulit, monooxide, no? So, you have to remove that. Take note. Examples. Number one, CS2. Di siya cesarean 2. Now, in medical field, CS means cesarean section or session. But CS2 in chemistry is calcium disulfide. We have, correct, phosphorus tribromide. Alam ko kahit malayo tayo, napapangalanan mo na sila kahit hindi ka ito naririnig, nararamdaman ko. Pinapalangalanan mo na yung number 3. At alam ko ang sagot mo dyan, diphosphorus pentasulfide. Number 4 is silicon disulfide. This is what I'm saying a while ago. You don't have to use mono. Ang pangit, no? Parang yung X mo, pangit. Monosilicon disulfide. Ang pangit. Diba? Instead of saying monosilicon disulfide, then that will be silicon disulfide. And Br3, that will be nitrogen tribromide. And N2Cl4, that will be dinitrogen tetrachloride. So that's how we name our binary covalent bonds. No, we have to use the prefix. Remember, prefixes will indicate the number of elements present, but prefixes is only used in binary covalent bonds. Correct. Tama ka, naririnig kita. No? Now, how about for determining the chemical formula of binary covalent compounds? Is it the same thing? The way how we write the chemical formula of ionic compounds? Then that's fine. Carbon tetrachloride. You have to write carbon. You have to write the chemical or the symbol of carbon, which is C. No? And chloride, Cl. 4 tetra Cl4. Okay? Another example, iodine heptasulfide. Iodine, I, fluoride, F, hepta, 7. Silicon disulfide, SiS2. disulfur hexabromide S2Br6, tetrasulfur tetranitrite S4N4, phosphorus trichloride PCl3. Okay? So that's how we name binary covalent compounds. Using the prefixes, no, that will indicate number of elements present or the number of each element present in a chemical formula. Okay? So that's it. That's the end of our discussion. No, the second part of the discussion will be given in our synchronous or session rather. I hope you were able to remember and take note on how we name covalent and ionic compounds. Again, this has been Sir Mark or Sir Mac, your instructor in chemistry, inorganic and organic chemistry, saying that you have to love chemistry because if you learn it to love, you will be able to understand. Love in order to understand. Thank you, and I hope you learn and enjoy again this video.